Do you use Blender and you want to learn geometry nodes, but the amount of tutorials online are so overwhelming that you don't even know where to begin? Well, then I have the course for you. This course is gonna create the famous Blender Donut completely procedurally using geometry nodes, touching upon all the basic principles that we use in geometry nodes to model and create. This course is intended for people who kind of know how to use Blender already. But if you don't, there are great tutorials that can get you started. Then you can come back here and learn geometry nodes together with me. So this course is split into 4 parts: making the dough, making the icing, making the sprinkles, and then texturing and shading the donut. Let's go into Blender and start making the donut. So this is gonna be the end result of this course. A donut with 2 types of sprinkles, some dripping, icing, a nice fried dough, and this is kind of an overview of everything we're gonna learn. So part 1 is gonna cover the dough, part 2 is gonna cover the icing, part 3 is gonna cover the sprinkles, and then we will jump into the shaders and create all of the materials that you see right here. So without further ado, let's open up a new Blender file and let's get started. So we're in a fresh file of Blender and we're just gonna get rid of everything and just add any random object. You can use the default cube if you want, but I'm just gonna make a plane. I'm gonna rename this into GeoNodes like so. And then we're gonna open up the Geometry Nodes workspace, which is a Geometry Nodes node editor. You can use the Geometry Node workspace here with the spreadsheet, which gives you a bunch of good data for analyzing what's happening and sort of keeping track of things and finding specific indexes and stuff. But we're not gonna use that today. We're just gonna go like this. And we click new, and we're gonna name this donut. So the first thing we want to do is just delete the group input because we don't need that plane at all. We're just gonna create everything from 0. So where do we begin? We need something to start with. And if you were to model this by hand, if you've done the donut tutorial, for instance, you would know that you would start with a torus like this. So we're gonna find something similar in geometry nodes. If you press this pin button here, this will never, even if you click away from the object, it won't disappear. This will stay here all the time, and we're gonna need that. So if we press Shift A and we get the menu and go into mesh, you will find here primitives, and when you look through these you will notice there isn't a torus primitive. There is a cone, cube, cylinder, grid, icosphere, mesh circle, mesh line, UV sphere. So none of these are really gonna work for us because none of them are a torus. The closest you will get is maybe the cylinder or the mesh circle, but we're not gonna use those either because in geometry nodes, if you wanna make a torus or something with an irregular shape that has, let's say it's a cylinder that's bent in a way, you don't typically start with meshes, you start with curves, and I'll show you in a sec why. So we're gonna actually go into the curve menu and in the primitives get the curve circle. And if we plug this into the geometry output, you will see a circle. Now this has a resolution and a radius. You can also change it to points, and then you can determine there's like 3 points like a triangle. So if I were to go to the minimum amount, these are the 3 points, and you can specify exactly where these are, but we're just going to use the radius and keep the resolution for now at 32 to start with. So what is the size of a donut, because we want to start immediately modeling this to real world scale. And you can look this up online, you can probably find something, but the best way in any case to make something in 3D, if you can get the real thing in your hand, you should. So I went out today to buy some donuts, and we're gonna use this as our reference. So let's grab this one. Look at that. Perfect donut to use as reference. So we can look at this donut and see how big is the radius. So I'm going to take this longer one. It's about, I don't have a measure right now, so I'm going to say it's about 10 centimeters in diameter. So back in Blender now we know that the diameter of the donut is about 10 centimeters. So if I were to type this into here, 10 centimeters, like this, it will of course be smaller, but it's still going to be the wrong size because we measured the diameter, or assumed the diameter based on how big the donut here was, and the radius is half of the diameter. So we can go ahead and divide this by 2. So we get 5 centimeters for the radius. We'll leave the resolution at 32 for now. We will change that later. And this would now be the outer edge of the donut. But we don't actually want it to be like that, because we're going to take another circle. We can duplicate that one. And we want to place this circle on the second circle on the first circle, and sort of spin it around to create the mesh of the torus object. And to do this, this new circle will actually be placed so that the center of this circle is on this line, meaning that the radius of this circle will extend out from here. So the big circle is going to end up in the center of here, and what's outside of it is going to be subtracted from the radius of the big circle so that we get the correct size of mesh. The inner radius of the donut is about 2 centimeters, so we're gonna put here 2 centimeters for now. And then how do we spin it around? We use a node called curve to mesh and put it in here. Visually nothing changes, but in reality it changes the curve into a mesh. So this is now edges instead of splines. And if we take this curved circle and put it in here, you can already see that we're getting somewhere, but we still haven't subtracted the radius of this here. And we're going to do this with math actually. So we're going to actually first start by getting a group input back, because we can, in geometry nodes, there is this empty slot here, and whatever we plug into here will show up in the modifier menu, so we can adjust individually the different parameters that we expose into the modifier stack. So we're gonna expose the radius like this. And if we go into the N panel, in the group sockets, we can call this the major radius. And we'll actually duplicate this item into the minor radius. So this, we can put a description here. Bigger radius of donut. And this one can be the inner radius of donut. The subtype is distance, meaning that it will be in meters here. And we will have the default value as 0.05, and the minor radius, we can put that as 0.02, like so. So the description will actually show up when you hover above the socket. It will say what it is. So if you're creating complex node systems, you can put some explanations of what things do, so people don't need to work out or test everything. They can just look at this text and it should explain what is happening. So then we will take this radius here and put it into the minor radius, which we will put default, like so. We will use a math node, set it to subtract. We'll put this now to 0 so it doesn't change anything. And if we subtract this value, we're getting closer. So now if I scale this up, it will stay the same width all the time. It's already looking a lot more like this donut. If we look at the mesh, you will see that it's kind of not square. So we want to actually expose some more things to this node tree, and we're gonna take the resolution, and we just want to move the resolution up. I think I want to have it at the start, so it's the resolution of the donut. And of donut. And if I were to plug this also in here, it would be the same, but we don't need as much geometry over here as we do around this way. So we're actually gonna go and get an integer math. It's the same as the math node, except it just handles integers. You could use this same node, but this just has the correct value type. So I don't think it has a significant difference, but at least it will be less bugs. So we're going to set this to divide, and we're going to divide it by 2. So now we have more square-ish geometry on this. Big thing when working with geometry nodes or any nodes in general, it's good to keep it clean from the start. So we're just gonna tidy this up. So that now is the base mesh of our donut. Pretty good. We're gonna move this over here, and we're gonna put a frame on this and call it do base, just to keep everything tidy and clean. What happens when you're creating mesh from curves, or mesh in general, when you're creating procedurally, it doesn't create UV maps. So we need to create those ourselves in the case that we would need them. And in this specific case, we won't need them, but I will still show how to do it, because it is one very useful and very powerful thing when creating assets with geometry nodes. Because sometimes you might need the UV maps, and if they're generated automatically based on the parameters that you have, it will make your life a lot easier. So to do this, we're gonna need a UV unwrap node. We are gonna set this into conformal, and it just has a UV output. So we need to output this somewhere. All objects that you create in Blender come as standard with the default settings with a UV map, and it's called UV map, exactly like this. And we can actually just overwrite this into this mesh. And to show you kind of what that looks like, I'm just gonna create a quick material, and we're gonna call it grid. And in this grid, we're just gonna put an image texture. If we press on new, we can call this grid. Like so. And choose the color grid, for instance, like that. We select this node, and we can close that up. And by the render balls, if you go here into object color and put texture, the texture should appear. But we haven't assigned this material to the object. Even though it is here, it isn't assigned to this geometry that's created, because we need to actually tell geometry nodes that this object should have this material. So if we search for a set material node, like so, and select the grid material, and if we go into rendered view and let's put an on an HDRI, you will see that it's just one color. It doesn't actually show up there. So we need to do the UV map. So to do this, we'll just move this to the side. We're gonna store a named attribute. UV maps are a 2D vector set to the face corner of the object, and it is called UV map, like this. And now you can immediately see that something is happening. And if I take UV unwrap and put it in here, nothing is working because we don't have any seams. If you remember from UV unwrapping, that seams are these red lines where the software knows that here I should cut the geometry when UV unwrapping. And we are going to want to do this sort of thing in Geometry Node. So we're going to need to figure out how to do this. So it cuts it around the circle this way and on the inside like this. So then we get a flowing continuous UV map this way. So we have to go back into the dough base for that. And before we turn this curve into mesh, we want to store some attributes on the curves. To do that, we're going to use again a store named attribute like this. And we're going to do one for each one. And this will be a type of Boolean. So it's a yes/no value, and we will call this SX and SY for seam X and seam Y. That's, you can call this anything, but avoid using terms that may exist as attribute types already, like words edge or seam or normal, because that may overwrite data in Blender to cause issues. So come up with creative names or use special characters to separate these attributes from data types that are generated automatically in Blender. So now we have to figure out where to put the seams and how. And for this case, if we have the node wrangler add-on enabled and we press shift control, we can get this viewer node so we can look at anything. And there is this input of value, and whatever type of value we put in like this, it will change the value type to something that works for us. And we're gonna get the index. And if I do this, you will see that it's there's a little bit of black here, and then there's white. So what is actually showing it 0, and then it goes 1, 2, 3, 4, and so on. If we drag out from here and type equals, we get this compare node, and we can have it where it equals to 0. So it's gonna just get this single point here. And we will take this and place it into this value. So now, if I look at this mesh and I take the named attribute of SX and look at that value, you will see that we have this white line here. And we can take this attribute and put it into the seam. So now something is happening, but we still haven't made the seam on the inside here. So we need to do that for the other one as well. So if we look at this one and we take this, we can take the same value here and it will be over here. We'll see if that works. So if I put this into the store named attribute for the small circle and then look at the full geometry and change this value into SY and look at the value, you can see that it's on this edge and we actually want it on the inside. So we're just gonna duplicate this node, put it in to here, and we can just click this until we have it in a place where we're happy. And and to make this procedural, because if I were to now change the resolution of this 64, you will see that the seam actually moves. So we're gonna take a group input node and do a integer math and divide by 4. So double the amount that we divided here. So then it will always stay on the inside over there, no, regardless of the resolution. So I put back to 32. And now we have this seam and this seam. So we need to now combine these two seams into here to UV unwrap this. So we can again look at the geometry and we will do a Boolean math. And if we place this in here, you can see that if we use the operation of OR, if I now put this OR value into the seam, you will see now that we have some UV maps that don't look amazing, but you can see that there's a seam here and there's a seam there. It's still very stretched though. I see angle based. Angle based is actually better right now. There we go. So setting this to angle based makes it better. It is not perfect in any way. In a perfect world, we would make this a square around. But for our use case now, we're gonna keep like this. So let's clean up the node tree once again, and we can to clean this up a bit more. If we are to change this value at some point, we can have it here, and we will multiply this by 2. So if I were to change this value, it will also put this value correct, so that all of this works correctly always, like so. So then let's put a frame around this. UV unwrapping. So now the next thing is no donut is perfectly smooth and round like this. donut we currently have here. So we want to make this donut lumpy, and this is something that you're gonna probably do a lot in geometry nodes, which is creating displacement. This is handy for creating environments or just making organic shapes or moving objects randomly, and we're gonna use some noise, a procedural noise, to create a displacement. The node to do this is a set position. To quickly explain, there are two typical ways to transforming geometry and it is the transform geometry and the set position node. And if you look closely on these nodes, you will see that this node has these balls and this one has these diamond shaped sockets. The diamond shape is a field, which means that this input can be different for each point in the geometry, whilst this is for all points uniform. So if I were to put this in here, this would always just transform all of the geometry. So this is a really good way to transform, move the geometry into different positions, or maybe animating the whole thing at the end. But however, this one, even though now when we look at it like this, it looks to do the same. You can't rotate with this, but you can move it because it's moving the individual points. So if I were to put a random value into here, and let's put a vector and put something small. If I were to put this, you will see that it kind of like it's moving all of the points in a random direction, randomly based on this. Now we don't want to use a random value, but this is just to demonstrate that it randomly transformed it. So if I were to put this to something really small, you would see kind of what it does. It just randomly takes all the points into different directions, and you can actually get some really cool results doing it like this, but we want something more organic and not as random. So we're going to use a noise texture instead. And noise textures have this color output, which correlates to the XYZ axes. So if I put this here into the offset, you will see that everything sort of shifts in all directions, kind of, if you look at the grid, it's sort of in the area of 0.5 because the noise texture is normalized to a range of 0 to 1, which means that the noise will average at 0.5 because there's equally as much pure white as pure black. So it's kind of in the center, it averages out to 0.5. But if we untick this normalize, you will see that it centers it back. Now this looks nothing like a donut because it is way too intense. So we can use a vector math node and use the function scale to scale the strength of this effect. So if we go down to something really small, you'll see now it is lumpy, but we still want to adjust kind of the size of this. And we're going to put this into 4D, so we get this W value, which we can use as a random seed. So we're going to immediately connect that into the group input, like so. And I am going to change this into the name seed and put it as an integer. So we change this into an integer, and we can put a description here to random seed of donuts. So we can use this value to randomize all of the different random seed values that we're gonna have, because this is not gonna be the only one. We're also have a random seed for the sprinkles and for the drips of the icing, maybe something else I can't remember right now. Now we want to kind of figure out what this is doing, because I'm not really loving the look of this. So I can look at the donut before it gets displaced and then look at this noise, and you can kind of see what it's like. So changing this value, this scale, to something like maybe 10 perhaps, and let's up the detail, then it's looking like that. Sure, it's a bit too intense, so let's put this to 0.003, and that I'm pretty happy with. So it's kind of like not perfectly round this way, and it's not perfectly flat in any way. So it has kind of this low frequency detail, and then a bit of high frequency detail. And if I were to up this resolution, you could kind of see that coming through. But we're going to do more of that detail in the shaders. So with the value of 0.003 and with these values on the noise texture, I am pretty happy with that. So put a frame on this and call it displacement. And now the final thing we want to do, let's actually look at the donut again. So we're gonna take the second donut that I have here, and it has this line here in the center, and this happens when the donut is frying in the oil. And then when you turn it over, there's this little section that's always gonna kind of get less fried than everything else. And sometimes that donut may bulge on the part that gets fried. And this center line will sort of maybe shrink a little bit. So we're gonna just push in that donut a little bit on that area to create the look for that shape, and then also store this ring around the donut that we can then later use in the shader. So let's dive back into Blender and check that out. To do this, we have to figure out where is the middle. And as we did earlier, we checked with the index and just kind of figured out where the inside of this is. This is one way you could do it, but since we already did it that way, let's go through a different way to find the center. And this is going to be using position. Position is an attribute for each point where it can tell you where in 3D space that point is. So you get kind of this gradient, and it's really dark because this is really small, so it's very near the 0, 0, 0 point. So we want to kind of normalize this so that if we were to scale this up, use different values, it wouldn't stay over here. It will always look at what's the maximum and minimum of the height to determine this placement. And to do this, we're gonna first separate this X, Y, Z. So then we get the X component, the Y component, and the Z component. And then we're gonna map range this like so. So in a world where this would never change size, we could just find where the value sort of becomes 1 and where it's 0. So we would have 0 here, 0 here, and 1 over here. And this is kind of the result we want. However, if I now were to change the radius like this, you will see that the black value is gonna go further away and the white value is gonna go like up. So it's probably like 1 somewhere around here and 0 somewhere around here. But we want 0 to be here and 1 to be here always, regardless of the size. So for that, we can use an attribute statistic, which has all of these different calculations it does based on the attribute you put in. So you could have attributes as vectors or floats, and it will give you the mean, the median, the sum, the minimum, the maximum, the range, and the standard deviation and the variance. We're going to focus on the min and the max. So if I take the z value here and put it into the attribute, it will give me the minimum value, which is something below 0, and the max value that is something above 1. And we can just take this. So the z component is in the map range like that, in the value, and then you put the min to from min and the max to the from max, and now we will have a perfect. The minimum value is 0 and the maximum value is 1. And if I were to change this radius, if I make it bigger, it will stay the same all the time. So I could just keep on scaling the donut and it will always be 0 to 1, no matter the size. Control H will hide all of the unused sockets. So we're going to keep that like so. We'll clean this up in a second. Then we can take this value and push it through a color ramp, for instance. So we can look at this again. And in this color ramp, we can put this white value into 0.5, so exactly in the center. And then we can take another one and make it black. And now we get this gradient that goes from 0 to 1 to 0 again. And we kind of just want to push this in 0.4 maybe, and then this to 0.6. So we get this kind of line. And then we can use a blur attribute. We're gonna set it to float. So we can blur this, and you can blur it as many times as you want. I'm just gonna blur it once so it's slightly softer, getting kind of rid of that jagged edge, just slightly just blurring it. Like so. So then we want to use that value, that line that we now created, and we want to do the same kind of thing as with the displacement. So we want to use a set position node and displace this with this value, but you can kind of tell that that is not working as intended, because we don't actually want to use this value here directly. We want to move the points in a specific direction depending on the point. And what direction would that be? Well, that would be the normal, pointing from the surface always out like this. So here it's going to be pointing this way, and we want to actually push it in the negative direction of the normal for each point. So on this side it will push in here, and on this side it would push in there. We're going to use the attribute of the normal. So there's the normal and the true normal. We're going to use the normal. So we can use a vector math set to scale, and then use this value here, put it in offset. So now it is doing something, but it is of course way too intense. So we can actually scale it before this down, and then you can see that it's actually moving the correct parts, but it's moving it in the wrong direction. So if I put this to minus 0.001, let's do 0.002, 3. There we go. So now you can see it has sort of this divot inside here. So it's the shape is starting to look a lot like a donut. And let's once again select all of this and put a frame on it and call this middle. Now I said we're gonna take this attribute and save it into the geometry and use it later for the shading. So to do that, we're gonna take a store named attribute, and we're gonna actually take it before before it displaces it. So that it is physically the same value. So we're going to take this value and put it in here and call it mid, like that. And it can be just a float on the point. And just to demonstrate, if I go into the shader and look at this, we get an attribute node, and in the geometry, if we type in exactly, case sensitive, exactly this mid here, you will see that we have it now in the shader, and we can actually use that value to drive the shader. So with that, we have now completed the dough for the donut. That is now, you can change the resolution of the donut. You can see how the resolution changes like that. We can have a different seed for the noise patterns, and then of course change the size if we want a ginormous donut. And you could also add any parameter. We could add this scale value to make sort of the divot stronger if we would want to, but I'm gonna leave it like that. And so this is what we created today. So that's it for this part of the donut. We created the dough and made it procedurally so that we can scale it, change the resolution, change the random seed. And in the next part, we're going to start creating the icing with some different techniques that we haven't used today. So watch that video right now, and I'll see you in the next one.